Okay, so I want to talk a little bit about elasticity of demand, and really it's the elasticity of demand to price. And the question that we ask here and that elasticity tries to answer is, when I increase price, what happens to demand? Or like you should be thinking, like this is like quantity demanded, right? And typically, just to remind you, in this book, we've been using P for price, and quantity demanded, we've been using X. So if you remember those demand equations where we had like P is equal to 500 plus 3X, or things like that, or we sometimes had X on this other side in terms of price. $25,000 minus 450p, something like that. These are both price demand equations. They relate price and demand to each other and talk about that relationship. Okay. So we know a few things. For most situations, we know that when I increase price and raise price, demand typically goes down. Fewer people want to buy the product if the price is higher. Okay. But the question really is, and we kind of have this general relationship. The question is, here, maybe by how much is maybe the question, right? So if I change price a little, does that result in a big or small change to demand? Right? Okay. So, and this question is the exact question about elasticity. So it says, is demand elastic or inelastic? Meaning kind of elastic demand. So let's talk about these two cases. Elastic goods or elastic demands, they are demands that have a big response, big drop in demand when price is raised a little bit. A lot of these goods and a lot of this information has to do with a lot of elastic goods have like substitutes available. So, for example, we might do like canned soup. Right? I go to the store to buy a can of Campbell's soup. It's $1.75 and the store brand is 75 cents. The demand for Campbell's soup will largely fluctuate because there's a ready substitute available. Same thing if you think about kind of the bread aisle. If you're just looking for kind of plain white bread or even like a plain loaf of wheat bread, typically you're a lot of times you'll make that choice based on price and kind of what's cheapest. Another really great example of elastic goods are airline tickets. And you'll see this, I mean, there's a million apps that will track sometimes $20 to $50 changes in an airline ticket and people will make decisions based on kind of small price differentials in airline tickets. So like that's a very competitive market, mostly because there are a lot of alternatives available, so consumers can easily switch from one to another without actually giving up that much, right? So they largely see them kind of as equal goods, maybe, and then price becomes a really important factor. Okay, so these are elastic goods that would have elastic demand, where we would see a big drop in demand when price was raised a little bit. Okay. The other type of demand we have is inelastic. And this is where demand is not that sensitive to price. Does not change much when I change price. It changes. I mean, like the general economic view is that if price goes up, demand goes down. But it's just that it will go down like a little bit. So, for example, these are goods that maybe you think of like that there's not really alternative, like from monopolies, or from things that maybe operate kind of like, so no alternatives. Or no kind of like things that consumers think are alternatives. So a great example of this is like the iPhone. Right? I mean, obviously there are alternative phones, but they're not really exactly like the iPhone. So this might, like the iPhone might even be different than, say, Android devices, for which there are several different and they're all running the same system. So iPhones are a great, Apple could raise the price of the iPhone probably pretty substantially without eating into demand that much. Largely gasoline as a good is inelastic. You see large fluctuations in gasoline prices across the market. And so without people really changing how much gas they have been using. This is different than like a specific gasoline. Maybe let's say BP raises their gas prices by 10 cents, but the Shell station across the street doesn't raise their price. You'll see that actually is elastic. You'll see a pretty good response in demand to BP raising that gas price. So, but largely kind of the commodity of gas, how much gas people buy based on like average price, is inelastic. Other things, maybe tap water. You probably aren't radically changing your behavior at home based on the price of tap water. Other goods, maybe cigarettes, are an example of kind of goods that are inelastic and that price can vary. Another thing that you might think about being inelastic is textbooks. So if you're wondering why textbook prices are so high, it's an inelastic good, and largely demand is unrelated to price. Professors choose textbooks, but they don't pay for them. And students have very little choice if they're going to fully participate in classes about whether or not they want to buy textbooks. So this is one of the factors that lead to kind of high textbook prices. Okay. So these are kind of some of the things that we think about. Okay, and so now I want to talk about how, like, none of this is mathy at all. We haven't done any formulas. So I want to talk about maybe the formula for elasticity. So elasticity is measured by It's this quantity E of P, and it's measured by a percent change in quantity over percent change in price. Okay? And largely in this section, the book is using a notation where they'll denote quantity, x, as some function f of p. Okay? So to find percent change in quality, we know that the derivative, f prime of p, tells us about change in quantity. Okay, so to find the percent change, so percent, I'm going to find this numerator, percent change in quantity is this change, f prime of p, and then I divide by the actual original amount, f of p. Okay, this gives you how, like, what percent change it was. Okay, you take the change, which is this piece, and divide by the original quantity. Okay. Now, I also have the denominator, so that's the numerator, right? So this is what I'm going to plug in. I'm going to take this, just to keep track, and plug it into this top piece eventually. Okay? Okay. So then I want to figure out the denominator. Percent change in, I won't use a delta, although we routinely use delta, and I think you see that in the book. Percent change in price. And for price, if we also think about this as like some function g of p, so what price is, it would just be the function p, right? I mean, like, that's price, p is our price. The derivative of that is just 1. Because p is this dependent variable. So this percent change in price is still the same thing that I did above, g prime of p over g of p, but because we know what these quantities are, it's just 1 over p. Okay, so in this box, I'm going to take and plug right here into the denominator. Okay, so I want to find this elasticity. So I'll have percent change in quantity over percent change in price. And this is f prime of p over f of p all over 1 over p. Okay, and I probably don't want to leave it like that. That's really kind of gross, this common fraction, or this compound fraction. Okay, so I want to remind you, like, this middle bar right here is, like, all of these are division signs, but this one is a division sign, and since I'm dividing two fractions, I'm going to rewrite it just the long way that we used to write division when we first learned it, right? Like this. If you remember, when I divide two fractions, I multiply by the reciprocal of the second fraction. So I multiply by p over 1. So this means this is f prime of p times p, which I'll put in the front. Usually people put in the front, over f of p. Okay. Now, this is a great candidate. Okay, I want to say we're trying to find elasticity. Okay, so this piece, p over f prime of p, p times f prime of p, over f of p, this is a great candidate for elasticity. It tells me how the percent that demand is changing over the percent change in price. Okay. It turns out if you calculate this quantity, price is always positive. This quantity down here in the denominator is always positive, but f prime of p, how quantity changes with price, is always negative. Quantity is always going down when we increase price. So this number is always negative. So elasticity numbers were always coming up negative, negative. All of them are negative. And just because we like working with positive numbers better, people introduced this negative into the formula so that they could just get positive numbers out and talk about them. So that's just a convention, but one that is very widely used so that you know. But that's why we use this. So I want to make kind of this conclusion just so that you remember these two kind of forms. Elasticity of demand is negative P, F prime of P over F of P. Okay? But it also represents, and I want you to remember this, percent change in quantity over percent change in price. So these are the two kind of forms that we use. The second one mostly to interpret what's happening in the problem, and the first one to actually form calculations. Okay, so I want to do a few calculations. Let's just find find elasticity. For this x is equal to demand equation 25,000 minus 450p. Okay, so this solution looks like this. I remember that E of P, this formula, if I'm just trying to find it, negative P, F prime of P over F of P. And really, I have these like 1, 2, 3 boxes. But 2 of those boxes I already know. So P just stays by itself, and F of P is given in the original problem. So really, I just need to find F prime of P, and then plug these 3 pieces into this formula. Okay, so F prime of P, if I look up here, I think is just negative 450. It's just a number. That's not always true. Sometimes it has p's in it, and we'll do another more complicated example, but I kind of want to do this simple one first. Okay, so I'm going to plug in these pieces. E of P is equal to negative P times negative 450. You also notice this derivative is negative, which we expect. And then over 25,000 minus 450p. I'm going to at least simplify this. These two negatives create a positive overall. And that this is my elasticity equation. Okay? Okay. And that is finding elasticity. Let's do one more of these. Find E of P for x is equal to F of P is equal to 98 minus 0.06 e to the p. Okay. So again, these are I need 3 pieces. It's negative, I need p. I need F prime of P, and I need F of P, but I already have P and F of P, so I'm going to find F prime of P, which is equal to 98, the derivative of 98 is 0. This negative 0.06 stays out front. The derivative of e to the p is just e to the p. That's it. Okay. So then I'm going to plug that back into this e There's several e's in here, so watch what I'm doing because I'm saying the letter e, but one's capital for elasticity and one's lowercase for this natural base. So negative p, negative 0.06 e to the p over 98 minus 0.6 e to the p. Again, these two negatives are positive, 0.6 pe to the p power over 98 minus 0.06 e to the p. And I will just leave that as my final answer.